Okay, so when you're multiplying, always multiply by the denominator. Don't always multiply by the number. So if you multiply by the denominator, you get 3.5 times s, which is an unfortunate variable to have when you have 5 next to it. And then you are going to divide by 3.5 to get s by itself. And again, we are going to round to the nearest hundredth just to keep it consistent. And then think about what your unit is going to be. And if you're not sure what it's going to be, find the same variable and see what it is in the story problem. So I always put the ... to represent that it keeps going and that I didn't round this. Okay, I'm only rounding this value here, and the 5 is telling me to push that up. So it's 7.49. And then, like I said, if you're not sure, this is S. That's the average speed. And here it tells you the average speed is in miles per hour. So it's going to be the same. It's miles per hour there. And that will be your final answer. Alright, now for number 9, I'm going to have you do the same thing where for step 1, I want you to write the equation. We are going to do the next step together because we aren't going to be rounding. We're going to be leaving our answer as an exact value. And I want to help you through some of that. Okay, so read through example 9, set up the equation, and then we'll check it. Alright, let's see how we did. So, again, whenever you're doing this on your own, I try to close in on how it varies. So, this has 2 ways it varies. It varies inversely and directly. So, this is the change in temperature, T, of an aluminum wire. Sorry, I apologize in advance because this is missing some things, and this should say wire, not an aluminum, right. So the change in temperature T of an aluminum wire varies inversely as its mass M and directly as the amount of heat energy E that is transferred. Okay, so I only wanted you to do this first step where you're setting up the equation. So the change in temperature T is equal to, and then we have 2 ways that it varies. It's inversely as M, so M goes in the denominator of the fraction, and directly as the amount of heat energy, so on the top it's K times E. Okay, so that's what I wanted you to have. How'd we do? Okay, because that was both of them together. Alright, so now what we're going to do is, first we're going to rewrite a few things. Okay, so the temperature of an aluminum wire with a mass of 1 kilogram rises 5 degrees Celsius. So I'm going to box in these important values, 0.1 kilograms. It rises 5 degrees Celsius when 450 joules, which is J. How many of you have done joules in chemistry. You guys in probably some of you are, some of you aren't yet. So it's when 450 joules of heat energy must be transferred. I combined two things together when I made this, and I'm sorry. Okay, so it says when 450 joules of heat energy, and we're going to have to add this little part in. So it should say of heat energy is transferred to it. I was doing a copy and paste job and did not go so well. Okay, so that should be the end of that sentence, okay? So a mass of 0.1 kilograms rises 5 degrees Celsius when 450 joules of heat energy is transferred to it. Okay, so that's enough information for us to find K, and then this part is missing the first part, so I'll give that to you as well. And then when you're finding the value of K, you're going to plug in which one's the temperature. 5 degrees Celsius. We know that temperature is measured in Celsius as one thing. The 0.1 kilograms, what's that going to go in for? Yep. Okay, and then of course the 450 joules would now go in for E, which is your energy. Okay, so we're going to plug it in without the units. Okay, so 5 equals K times 450 divided by 0.1. Alright, so just like we did before, first step, always multiplying by the denominator. So we're going to multiply both sides by 0.1. Okay, and 0.1 times 5 is just 0.5. Okay, now we have 450 times K. So we would just divide, but like I said, for this I'm going to help you with it because we're going to leave it as an exact value, not as a decimal. And here's why. When you divide this, 0.5 by 450, do you guys notice anything special about this decimal? It's a repeating decimal. So we can write it as a fraction. That's what we're going to do. There are a couple different ways that you can rewrite this as a fraction so that it's an exact value. Do you guys have any ideas on how you would get that decimal out there? Because there's a couple different ways you can do it. Do what? Did you say plug it in over 90? Oh, okay, yeah. So you could divide the top and the bottom by 0.5. Yep. And when you divide something by 0.5, it's the same thing as multiplying by what? Yep. So you could multiply it by 2. I think that's the easiest way. Do you guys know another way you could do it that would work with any decimal in the tens place? Multiply by 10 over 10. Because then it would move it one place over. Okay? So if you multiply by 2 over 2, which remember is something that we talked about in our rational function algebraic stage, 2 times a half is just what? 1. 2 times 450? 900. Okay, so this is your K as an exact value. So you guys are going to be taking the PSAT next week. And one thing that you might see in directions is keep it as an exact value or a rounded value. So exact means you're not rounding it. Yeah, and we'll talk more about it. And so because we are doing that, we're also going to talk about some equivalent forms. So your equation, I'm perfectly fine if you write your equation like this, 1 over 900 E divided by M. That is perfectly fine for this class, okay? When you are taking standardized tests, though, you do have to be able to manipulate equations to see which ones are equivalent, okay, an equivalent form. So I'm just going to remind you of some things that you already know about how to simplify. So if you were to simplify this, this is something that we talked about when we were doing complex fractions. Remember, this fraction bar means the same thing as dividing. So 1 over 900e divided by m, you could just do your keep, flip, change. So let's think about how that would look, right? Your keep, flip, change. So you would keep this the same. We're actually going to simplify it a little. You would change that to multiplication. And then, do we remember how to flip a whole number? Yeah, it would go over 1. When you're multiplying a fraction times a whole number, you multiply it by what part of the fraction? Numerator. Yep, because this is like e over 1, right? So e times 1 is e. 900 times 1 is 900. So you could rewrite this as e over 900. We're going to change that to multiplication, and then we're just going to flip it. So m goes on the bottom, 1 goes on the top. And then you just multiply fractions straight across. Okay, so if you multiply e times 1, you get e. 900 times m, you get 900m. And so this would be an equivalent equation. Right? And that word equivalent just means they're the same, they're just written differently. They're equal, they're written differently. Okay, so that would be another way that you could write it. Again, this class, this is fine, but you can manipulate equations. So if you're ever on a standardized test and you got an answer that you know is correct, just know there might be an equivalent form. Okay? All right, so I cut off the question, so we're going to have to add that part in there, okay? So the thing that says it must be transferred, what comes before that, we'll just put a little star that this is where it goes, okay? The question is, how much heat must be transferred? How much heat must be transferred to an aluminum wire with a mass of 0.2 kilograms to raise its temperature to 20 degrees Celsius? Okay, so that, if you don't have that in there, it really does not make sense. So how much heat must be transferred to an aluminum wire? And it gives you the mass of 0.2 kilograms. You want to raise its temperature to 20 degrees Celsius. And the how much heat means that you are going to be finding the joules. Okay, so you have to find E when your mass is 0.2 and the change in the temperature is 20 degrees Celsius. Okay, again, you could use either equation for that. I think most of you, when you're doing this, will plug it into this formula so we can practice solving that. So 20 equals 1 over 900, and then we're finding E, so it's just times E divided by 0.2. Okay, so we're going to start by multiplying both sides by the denominator, just like we've done before. Okay, 0.2 times 20 is going to give you 4, and you have 1 over 900 times E. How do you move over 1 over 900? Times by 900. And we can do things like 4 times 900 without our calculator, right? 4 times 9 is 36, and you just add your 2 zeros on. Okay, and then your last step is just to write it with your units. So this is going to be in joules. That is your heat energy.